All right, this is going to be notes 26, negative exponents. And these can get a little bit weird, okay? But here's the idea. Negative exponents, right, this little number that's negative, does not necessarily mean that your answer is a negative, okay? What it actually generally means is you're going to create a fraction for me. So what you want to do is anything that has a negative exponent, you want to think about where it is in a fraction. So right now I could write this over 1. So this term is sitting in the numerator of the fraction with a negative exponent. It is not happy. So we are going to move it and we're going to make it happy. And so that means we're going to take this term and we are going to move it into the denominator. But when you move it, that power becomes positive. Okay. Now, you cannot leave the numerator of a fraction just blank. All right. There's no such thing as that fraction. So you can put a 1 there. And so 1 over 2 squared. 2 squared as by itself, 4. So that becomes 1 over 4. Now, a couple of reasons why this works. Okay. And I'm going to show them to you so you understand this isn't magic. This isn't just, oh, you said so it works. If we start off with, let's say, 2 to the 6th over, whoops, write the right thing, 2 to the 4th. Nope, I did that wrong. Haha. I'm trying to make it work. There we go. So 2 to the 4th over 2 to the 6th. I knew I was going to get it right eventually. Quotient rule would tell us that we get to subtract these exponents. And so 4 minus 6 makes negative 2. Cool, great. But that doesn't really tell me what it equals. So let's say instead that I were to write this out. So 2 to the 4th means I have 1, 2, 3, 4 2's all being multiplied together. 2 to the 6th means I have 1, 2, 3, 4, 5, 6 2's being multiplied together. And one of the things we've talked about when we do fractions, we deal with multiplying and dividing fractions, is I can cancel things out, right? 2 over 2, that leaves me 1's. 2 over 2, those leave 1's. 2 over 2, there's some more 1's. And hey, look, there's another 2 over 2 with 1's. So let's figure out what I got across the top here. Well, in the top, I've got 1 times 1 times 1 times, I got a whole bunch of 1's. And in the bottom, I have 1 times 1 times 1 times 1 times 2, which is 1/4. So mathematically, these two things are identical. So anytime you have a negative exponent, wherever it is negative, if it's in the numerator, we're going to move it to the denominator, make it positive. If it happens to be in the denominator, we can go ahead and move it up to the numerator to make it positive. So I can still see part B, so I'm going to leave this work that I have here and move on to part B. So immediately I'm going to rewrite this as a fraction, 1 over 3 to the positive 2. And I know that 3 squared is 9, so 1/9. So 3 to the negative 2 is 1/9. All right, I'm going to go ahead and scroll on over. Oh, look, part C, we've got a 2-part problem. Now, before you can add, right, this is definitely addition, we have to deal with these exponents. All right, so the first fraction, this is going to be 1 over 2 to the positive 3 plus 1 over 3 to the positive 2. Now, this one we just did in this last problem. So I'm not going to rehash it, right? We just already know that this is going to be 1 over 9. Keep in mind, right, 2 to the 3rd does not mean that you have 2 times 3. It means you have 2 times 2 times 2, which is actually 8. All right, so now we've got 1/8 plus 1/9, which is honestly a problem I've probably asked you to do probably a couple of times if you're doing your homework and things like that or practice. So we need a common denominator, and the common denominator for 8 and 9 is 72. There's not too much common there. So to get 8 to 9, 8 times 9 makes it 72. So times 9 here. 9 times 8 makes 72, so times 8 there. And if I put it all together, 9 plus 8 makes 17 over 72, which is a fabulous answer there. All right, so that's part C. A little bit of extra work there. Now, this is part D, where I was talking about what happens. Not all of these create a fraction. In fact, this, right, is in the denominator. So we're going to move it up to the numerator. Okay, so we'll leave the 1 alone, and this is going to be times 4 to the positive 2. So that's going to be 1 times 4 squared is 16, so a grand total of 16 here. Okay, and then I think part E is the last, yep, part E is the last one here. So let's go ahead, that 3 stays. Why is the 3 staying? Because the 3 has a positive, there's no negative exponent here. All right, if anything, it would be 3 to the first. 1 is definitely positive. We're going to go ahead and move this 2 to the second, right? Move this up here, so it becomes one entire little expression. So we've got 3 times 2 to the second makes 4. 3 times 4 is 12. All right. So negative exponents, I want you to be super careful about because they do not necessarily mean that you're getting negative answers. In fact, if you look at what we did here, not a single one of these problems is negative. That doesn't mean they can't be. It just doesn't mean it's automatically a negative. All right. This is where I'm going to go ahead and cut the video. I'll put another video up for part, I guess, 3 on the graphing line section. But as always, if you have questions or concerns, please do let me know.